Okay, your favorite thing, factoring. We are going to solve quadratics by factoring. We are going to talk about all the different kind of ways today because this is review from Algebra 1. So first of all, when I ask you to solve a quadratic equation, we're looking for all of the x values for which y equals 0. This is why one of the synonyms for solutions is 0. Finding the zeros. So we look for the solutions, we look for the zeros, we look for the roots, and we look for the x-intercepts. All of those are looking for the same thing. So this is one that already looks factored. This is in factored form, which we already talked about when we were graphing in intercept or factored form. So when we're after we have factored a quadratic equation, what we do is we set each part equal to 0, and then we we solve it. So here I take the n minus 6 and set it equal to 0. I take the n minus 1 and set it equal to 0. So when I add the 6, I get n equals 6. And when I add the 1, I get n equals 1. So these are the two solutions, the two x-intercepts, which reminds you that when we see minus 6 in the parentheses, we always know it's a positive 6 on the x-axis. Same with this one. When we see minus 1, we always know it's a positive 1 on the x-axis. So these are our x-intercepts. So if I look at another one, I have x plus 6 and I set that equal to 0. I have 5x minus 1 and I set that equal to 0. So to solve, I subtract 6 from both sides and I get x equals negative 6. To solve this one, I'm going to add the 1 first and divide by the 5 to get x equals 1/5. So these are the two x-intercepts for that quadratic function. Now, if we have them written in standard form, we are going to want to factor in order to solve these. So for factoring, the first thing we look for, factoring steps. The first thing we always want to look for is a greatest common factor. After we've looked for a greatest common factor, we're going to try to pay attention. Do we have two terms? Wait a minute. Yeah, two terms. So then we can use square root if we do that, if we have that. Do we have three terms? And teachers call it all kinds of different ways to factor a trinomial. I tend to say AC method. I think that's a popular term. Not really sure what your teachers in the past have called it. We might even see four terms. And if we see four terms, we use grouping. All right, then we would set each factor equal to 0 and solve. So let's look at number 3. The first thing I'm going to look for is the GCF. I actually do have two terms. So when I'm looking for the GCF, I list all the factor pairs. So for 6, the factor pairs are 1 and 6, 2 and 3. And then I have p squared, so I have two of them. For my 36, and I do have to remember this minus sign here because that's the same as a negative 1. I have 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. So, and a p. So I'm looking for the greatest common factor. So what do both of these have in common? And I want the greatest, so I'm looking for the largest, okay? The largest number both have in common, or all three if you have three terms. Okay, so the easiest way to do that is to look at the largest numbers. So 36, obviously there's not one here. 18, no. 12, no. 9, no. But 6, I do have a 6. Okay, now I'm going to look at my variables. I have one p here, and so I match these two p's. I cannot factor out another p here. I am finished. So my GCF is 6p. So to factor this, I'm going to put the 6p out front. And then I put my leftovers in the parentheses. So when I factor out a 6p, I have left 1p, or just p. And here I have this -1 or -6. So I factored. Now to solve, I'm going to set each part or each factor equal to 0 and solve. So here's a factor, 6p. Set that equal to 0. And here's a factor, p minus 6. Set that equal to 0. So here I divide by the 6, and I get p equals 0. Here I will add the 6 and get p equals 6. So I have two solutions here. These are the two spots that my quadratic graph will cross the x-axis. How about for this trinomial here? So again, I'm going to look for a GCF first. That's always the first thing I look for. And I know, because I know my times tables, 5 divides into 40 and to 60. So I know my GCF is going to be 5. If you do not know your times tables, you have to make your lists. Okay? I'm going to take the shortcut because I know my times tables, and I'm going to write 8 times 5. And here I'm going to write 12 times 5 because I know 5 is the largest number that can be factored out. Okay, I do have 2 k's here. I have 1 k here, and I have no k's here. So that means the k cannot be part of my greatest common factor. All right, so my common factor I already said is going to be 5. Again, can't factor out a k from the third term, so that's not part of my GCF. And so what do I have left? I have a 1 and a k squared. Here I have a -1 or a -8k. And here I have a +12. All right, so now that I have factored out my GCF, I know that I have 3 terms. So this is where I use my AC method. So I have a 1 for A and a 12 for C. So I multiply those. 1 times 12 is 12. What are my factors of 12? 1 and 12, 2 and 6, 3 and 4. This is a positive, but I'm looking for the pair that when I add them together, I get a -8. So I need, since when they multiply, they get a positive, everything is going to be negative. So -2 plus -6 is 8, and -2 times -6 is 12. So I know these are my two factors. So what do I do with that? I will keep my 5, don't get rid of that. I will keep my k squared. I will keep my plus 12. In the center, I will put minus 2k minus 6k. And now I will group. I will group my first two terms together. What do k squared and negative 2k have in common? A k. So k times k is k squared. If I factor out this k, I'm left with minus 2. Now, if I look at these two, negative 6k plus 12, what do they have in common? Hopefully, you can see that they have a 6 in common. Put that in the wrong spot. Now, if I do this, if I factor out a 6, I have a negative k plus 2. And what should happen is I should have two binomials that are the same, k minus 2, and I should have k minus 2 over here, but I don't. Hopefully you can see that the only difference is that my signs are swapped. This is positive, this is negative, and vice versa. So what I can do is I can factor out a negative 1, which is going to make this the way I want it. So when I do that, I have k times k minus 2, because this does not change. Factor out that negative 1, so this is now negative 6. This is now positive k. This is now minus 2. So now I have the two binomials that should be the same. So that's another common factor that I can factor out. And when I do that, that leaves me with k minus 6. And please do not forget the 5 that we originally factored out. So if we set each one equal to 0, if I set 5 equal to 0, that's kind of like extraneous. It doesn't affect anything. I take k minus 2, add the 2 over, and get k equals 2. And then I take k minus 6 equal to 0, add the 6 over, and get k equals 6. So my two solutions are at 2 and 6 on the x-axis. Okay, for number 5, if you look and you see that you have an a value of 1, then there is no possible greatest common factor. If you look or of numbers, I guess, if you look at your variables and you have a variable in every spot, then you have a variable that can be a greatest common factor. For this one, we do not have a greatest common factor, so we will go directly to looking for our factors of 1 times 6, which is obviously just 6. And so this is what we have. So where we need the factors that add up to give us a negative 7. Once again, they multiply to give me a positive. They add to give me a negative, which means they both have to be negative. And so which pair gives me a negative 7? This pair here. So I have x squared in the front, positive 6 in the back, negative 1x, negative 6x. So looking at my first two, I have an x in common, which I will factor out. After I take out 1x, I have another x left. After I take out that x, I have a minus 1 left. And if you think about what we just went through with the example number 4, hopefully you will see that my signs are switched again, and then we could go ahead and take care of it. I know that I need to factor out a negative 6 here. That will leave me with a positive x and a negative 1. So when that happens, we have our binomial that is the same. And we have left over x minus 6. Oops. If we set each one equal to 0, we get x equals 1, and x minus 6 equals 0 is going to give us x equals 6. So that's a nice simple trinomial to factor. When I look at number 6, I see once again that I have an a that is not 1. But I know that 7 divides into 35 5 times and 7 divides into 28 4 times. So I can look at this and know that 7 is my greatest common factor. So 5 times 7 is 35. 4 times 7 is 28. So if I factor out a 7, I cannot factor out an m because there is no m in my third term. So what does that leave me with? M squared plus the 5m plus 4. Now I'm going to factor this trinomial. My factors of 4 are 1 and 4, 2 and 2. Everything is positive, so this is nice and sweet and easy. 1 plus 4 is 5. 1 times 4 is 4. And so I have my m squared in the front, positive 1m, positive 4m, plus 4 in the back. My GCF of the first two terms is m, which leaves me with 1m here and a 1. My GCF of the second two terms is a 4, which leaves me with an m and another 1. So I got what I wanted. And I have my leftovers of m plus 4 that will go here. And do not forget the 7 that we factored out in the beginning. So to finish this up, 7 does not equal 0. We throw it out. M plus 1 equals 0, or m equals negative 1. M plus 4 equals 0, or m equals negative 4. Those are my two solutions. If a quadratic is not in standard form, I must rewrite it first. So here's my equal. The most common mistake you guys make when you are rewriting these is you do not change your signs. But remember, if I move this k over here, then I need to subtract it. That makes it a minus k. And if I move the 42 over there, that makes it a minus 42. Now, I will tell you, you could subtract your k squared and only have one thing to move, but a negative a when you're factoring causes all kinds of havoc. So I would not do that. All right, I have a nice little trinomial with a is 1, and so I'm going to show you a shortcut. 1 times negative 42 is negative 42. The factors of 42 are 1 and 42, 2 and 21, 3 and 14. Not 4, not 5, but 6 times 7, and that should be it. And this time I have a negative 42. So when I multiply, that means only one number can be negative. I want them to add together to give me a negative 1. So if I look, I know that 6 plus a negative 7 gives me a negative 1. This is my pair. So here's my shortcut. When you have a leading coefficient of a, you can take that k squared and split it up into two sets of parentheses, put the positive 6 in one and the minus 7 in the other, and that's the shortcut. That only works when you have a leading coefficient of 1. So setting each one equal to 0, I get k equals negative 6. Setting this one equal to 0, I get k equals 7.